Then now here what do we have? We have T1x plus W1x plus N1x is equal to MAX, and we are interested in determining AX. So T1x is given by plus T1, W1x is given by minus W sine alpha, and N1x is 0, which is equal to MAX. So here recall that they are asking us to determine the acceleration A1, so let me say that this is A1, so A1x. Then we are interested in determining A1x as function of M1 G sine alpha and T1. So T1, then W1 can be written as M1 G sine alpha, which is equal to MA1x. Now flipping these quantities and dividing by M, we get that A1x is equal to T1 minus M1 G sine alpha divided by the mass M1. And now we are interested in the acceleration and not in the x component, but we know that A1 is equal to square root of A1x squared plus A1y squared, and this is 0 because there is no motion along the y-axis, so this is simply A1x, which is given by that. So then we have determined the value of A1, which is given by T1 minus M1 G sine alpha divided by M1. Okay. Now similarly, if we want to determine the acceleration A2, so okay, so we are done with parts 1 and 2. Now for part 3, they are asking us to calculate the acceleration A2 of S2 as function of M2 G sine beta and T2. So here it will be exactly the same. Now I will do the explicit steps, but one can directly inspect and check that the value of A2 will be given by. Now there is here a difference in sign. This will be minus, this is plus, because the direction of motion will be downward along the inclined plane. So the acceleration A2 will be given by minus T1 minus T2 plus M2 G, the angle is given by beta sine beta, divided by the mass M2. But let's do it explicitly, and let me consider, so here we are in part 3, let me consider that this is the positive direction of the x-axis, which is downward, and we have the weight which is vertically downward like this, and we have the normal to be like this. Okay, so this is the normal, this is the positive y-axis, this is the x-axis, this is the weight 2, normal 2, and we have the tension here along the string, which is tension T2. So now let's see, apply Newton's second law. For S2, we have sum of forces is equal to M2 A2, so the weight 2 plus the tension T2 plus the normal N2 is equal to M2 A2, and we are interested in determining the acceleration. This is a vectorial equation. Let me determine the projections here. We are interested in determining the projection of W2x, W2y, the tension T2x, T2y and N2x and 2y. So regarding the weight, it is acting in the positive direction of the x-axis. If this is beta, then this will be pi by 2 minus beta, then this is pi by 2 minus beta. So without no exception, always the x component of the weight, it's given by w sine beta, in which beta is the angle of inclination. In this case, it's minus w sine beta. And for w2y, it will be plus, sorry, this is plus because it's pointing in the positive direction, and this will be minus w cosine beta. T2x will be minus t2, and this will be 0. N2x will be 0, and N2y will be plus N2. So now projection along the x-axis. Now simply we drop down the vector quantities, and each vector quantity will carry the label x. We have w2x plus t2x plus n2x is equal to m2 a2x. We are interested in a2x. w2x is simply given by minus w plus w sine beta. T2x is minus t2. n2x is 0, and this is equal to m2 a2x. So a2x is equal to, now if w is replaced by m multiplied by g, then it's given by m2g sine beta minus t2 divided by m2. And we know that a2 is equal to square root of a2y square, a2x square plus a2y square, and this is 0, no motion along the y-axis, so it is a2x. Then the acceleration a2 of the block is given by m2 g sine beta minus t2 divided by m2. Okay. So which is exactly the expression that I have wrote at the top, okay? But the order of these two terms is reversed. Now as for, so we are done with number 3. Now in part 4 they are telling me to compare the acceleration a1 with a2, and sorry that here I should also mention the following note, I have forgot. So here let me also say that if we refer back to this section, to the previous notes, we need to say that v1 is equal to v2. So the speed of this block is equal to the speed of this block, and the reason is given by an extensible string. Because if the string is inextensible, so it is always stretched. If this solid is displaced by a displacement delta x, then this will be displaced also by delta x, and time is absolute. Time is the same for s1 and s2. For this reason, the speed will be the speed of s1 and s2 are equal, because the string is inextensible, because the speed are equals at all instant, we have that a1 is equal to a2. So these are the different conditions that we are interested in whenever we are dealing with problems related to a pulley. Okay, so these are the conditions that we need. Okay, so no more conditions other than this. So they are telling me to compare a1 and a2. Without referring to the expressions of a1 and a2, we can directly say that a1 is equal to a2. By compare, we need to say greater, less, or equal, and this is the reason given by an extensible string. And in this case, t1 is equal to t2. They are talking here, so what does t1 and t2 refer to? t1 is represented here and t2 is represented here. Okay, so this tension is equal to this tension, and the reason is given by an extensible string. This tension is equal to this tension, and the reason is an extensible string. Now this is equal to this because it is inextensible and the pulley is of negligible mass. Here they are telling us a light pulley. So sorry, this is a light pulley. So because this is equal to this, then this is equal to this. So T1 is equal to T2. The reason is given by an extensible string and a light pulley. Then this is it for part 4. Now finally in number 5 they are telling us deduce the acceleration and the magnitude of the tension of the force in the string. So we want to determine the acceleration, but in order to determine the acceleration we need first to determine the tension. Okay, so here what we will do is that now if you want to solve this part in this order, first to determine the acceleration and then to determine the tension, we need to solve in the following way. Now if A1, so now if we cross multiply, we find that A1 M1 is equal to T1 minus M1 G sine alpha, which means that A1 M1 plus M1 G sine alpha is equal to T1. And for this expression, if we cross multiply, then A2 M2 is equal to minus T2 plus M2 G sine beta, which means that A2 M2 plus T2, minus M2 G sine beta is equal to minus T2, which means that minus A2 M2 plus M2 G sine beta is equal to T2. Now we want to solve for the following equations for the acceleration. So let me say that A1 is equal to A2 is equal to A, T1 is equal to T2 is equal to T. Then let me rewrite equations 1 and 2 in the following form. We have that A M1 plus M1 G sine alpha is equal to T, and minus A M2 plus M2 G sine beta is equal to T. If we want to find the acceleration first, so we will simply say we will try to eliminate A by comparison, so T is equal to T. Then the equation is reduced to A M1 plus M1 G sine alpha is equal to minus A M2 plus M2 G sine beta, which means that A multiplied by the total sum is equal to, here what do we have? We have M2 G sine beta minus M1 G sine alpha divided by, now we can divide both sides by M1 plus M2. So what do we get? We get that the acceleration is given by so if we try to take G as a common factor, we have a G, or let me keep it like this. It is suppressed by the total mass of the system undergoing motion. We have M2 G sine beta minus M1 G sine alpha. And now let me interpret this result and relate it to the first part. So notice that here in this case, previously in chapter 7 we have discussed why usually we get such type of expressions. So the acceleration in such type of exercises, it is always divided by the total mass, because always acceleration is given by force divided by mass. So mass is always additive quantity, we do not subtract mass, and for this reason the acceleration will be divided by the total mass. But we know that the forces is an additive quantity in a sense that we add the forces, but we need to consider that the force is a vector quantity in which there is a plus or a minus sign that is involved. Now, why m2g sine beta minus m1g sine alpha? Because in the first part we have compared that and said that m2g sine beta is greater than m1g sine alpha. For this reason, the direction of motion will be in terms of the solid S2. This term here, it represents the force exerted on the solid S due to Earth, which is the weight, and the same for S1. So the difference in these two quantities will give us the acceleration A. Why this is plus and this is minus? Because S2 is in the same direction of motion while S1 is in the opposite direction. Remember that one can always think about this equation. So for example, if one directly want to calculate the acceleration, okay, without doing any calculation, one can say that the acceleration is given by force over total mass. So the total mass is m1 plus m2, and here in the numerator, because we know that the direction of motion, it is in the direction of S2, so it will be the weight of S2 along the x-axis, which is m2g sine beta, because remember always the weight along the x-axis or the acceleration is suppressed by the factor g sine beta. As for the solid S1, it is simply in the opposite direction of motion, so it's given by m1g sine alpha. Okay, this relation always hold if the pulley is of light mass. Otherwise, here we expect that there is another factor due to the mass of the pulley, and the tensions, they will not be equal. So here the tensions, they doesn't appear in the force because simply they eliminate each other. Now if you want to calculate the numerical value of this acceleration, we have m1 is equal to 3 and m2 I think is given by 2 kilograms if I'm not wrong. M2 is equal to 2 kilograms, right? And sine alpha is equal to 0.3 and sine beta is equal to 0.5 I think. Right. So now let's calculate the numerical value of the acceleration. So 2 multiplied by 10 multiplied by 0.5 minus 3 multiplied by 10 multiplied by 0.3 divided by the total mass, which is 3 plus 2. Now directly this with this gives us 1, so it's 10. This with this will give us 3 multiplied by 3, which is 9. So 10 minus 3 divided by 5, which is equal to 1 over 5, which is equal to 0.2 meters per second square. So the acceleration of the system is given by 0.2 meters per second square. Moreover, they are telling us to determine the tension force in the string. So one can determine the tension either using this equation or this equation. The answer will be the same because we have solved them under equating them. So let's refer to T is equal to A m1 plus m1 g sine alpha. Okay, so the value of A is given by 0.2 multiplied by the mass m1, which is 3, plus 3 multiplied by 10 multiplied by sine alpha, which is given by, let me see, 0.3. So this is 0.6 plus, okay, this is 3 multiplied by 3, 9. Now how come this is 0.6 compared to this value, which is, let me check the acceleration again. Let me check the value of the acceleration if it's correct. Yes, so everything is correct. Now this is equal to 9.6 in newtons. Okay, so the value of the tension is given by 9.6 newtons. So that's it for me in this video, guys. And the next part we complete solving exercises on this chapter.